In this lecture, we'll see this example. Determine whether a relation which is defined by an equation here, y equals x squared, defined by an equation. In this case, the equation is y equals x squared, is a function of x. So we want to see if an equation actually defines a function or not. An equation may not define a function. Now, to see if the equation defines a function, let's first input some values for x first. You see, we may input -2 here, and then we know -2 squared is 4, -1 squared is 1. We input 0 into x, and then we have 0 squared is 0. We input 1 here, and 1 squared is 1. We input 2 into x, and then we have 2 squared is 4. So basically the pairs, you can see -2 corresponds to 4, so -2, 4. -1 corresponds to 1, so -1, 1. 0 corresponds 0, 1 corresponds 1, and 2 corresponds 4. From these pairs, we can see that each value of x is defined only once. You see that when you sort based on the x from the smallest to the biggest, you can see each value is defined only once. Okay, and then when you put those pairs on the graph, you see -2, 4 is this one, -1, 1 is this one, 0, 0, 1, 1, and then to 4. There are 5 points. You connect it with a smooth line, then you have the graph. So when you draw a vertical line, you see the graph passes the vertical line test. Okay, we say pass is because this vertical line can intersect with the graph at most once. Okay, it does not intersect the graph twice or more. So it only intersects the graph at most once. So in this case, we see the graph passes the vertical line test. Okay, so that's important thing. Some of you probably already noticed that for the right down here, for the same value y, you see 4, 4, they have a different values for x. But here we say it is okay that different values of x which correspond to the same y. So you see -2 corresponds to the 4. Another different value, 2, also corresponds to the same 4. It is okay for doing that, but it cannot be like -2 goes to the 2 different values. Okay, the different x can go to the same value, but one x cannot be defined more than once, or that's to say 1x cannot be corresponds to more than 1y. Okay, so here is very important. You may want to think about those two statements for a while. Okay, so anyway, pass the vertical line test. Yeah, the vertical line has at most one intersection with the curve, then we are okay. It will meet these two. All right. Now, we have the points. We have the graph. Okay. Now we know then the equation, the conclusion is that the equation defines a function of x. Okay. Now, here the function of this equation is actually take the input. X we call it is the input. You input any values here, then you square it, okay, and give output y. That's basically the function of the equation. So we like to denote by f, means the function of this equation, okay, is take the input, so we use parentheses and then input, and then output is y. Output is y. So you see here again is input x can be anything here, -2, 1, -1, 0, 1, 2. Okay, so basically the input we take and then we square it. We square the inputs and then we give the output. So we write in this way. Okay, you put the input right here. Yeah, this is also the input. All this column, -2, 1, 0, -1, 0, 1, 2. Okay, and then you square the inputs, you get output. So again, then -2 here, and then 4 here. -1 here, and then 1 here. 0 here, 0 here. 1 here, yeah, 1 here. And then 2 here, 4 here. Okay, 2 here, 4 here. All right. So f of x is not f times x. Is the function, f stands for the function. Take the input, square the input, give the output. So here all the values of y depends on the input. You see we got 4 is because we input -2. So this y is also called dependent variable. And x, it depends on us. We can input anything. So here then x is called independent variable. Okay? That's the notation we want to understand. Now, you see right here, x can input anything positive or negative, whatever you input. So here we say the all possible values of x is actually the domain. Okay, and then negative, from negative infinity to positive infinity, because it takes what? It takes negative number, it also takes positive number. So from negative infinity to positive infinity, that's all the possible values for x. But for y, that depends on x. You see, any value you put in there, you all get positive. You can never get negative. That's why we say all possible values of y is from 0 to positive infinity, and 0 is included, so we use square bracket to indicate 0 is included. Okay, again, to the positive infinity, but positive infinity was never included, so you want all the time to use round bracket for positive, for the infinities on two sides. Okay, that's the thing we need to understand. You know, here I only used integer as the example. Some of you, say, can we put fractional number there? Okay, you can, but right now we may not do that. Okay, so this is basically the definition of the function. I'll see you next time.